Morning, students. In today's session, we will deal with different types of page replacement algorithms that we have in order to effectively manage the memory system of a computer system in general. So, a basic question comes to our mind, that is, why do we need page replacement? Now, as I've told you in the earlier sessions, when the concepts of paging and virtual memory came into existence, after that we were viewing we were viewing a process as a collection of some pages, and those pages needs to be loaded into the physical memory for their execution. But the thing is that we can start a process even with loading only a few pages of that process into the memory. So that is the concept of virtual memory. Now, when we are employing virtual memory in our machines, then what is happening? So basically, our physical location so the physical location of the various processes are being diminished, or each of the processes are getting a very finite amount of physical memory. And as a result of that, they are also getting a finite number of limited number of frames to work with. And ultimately, each of the processes are getting only a fixed or few number of frames to carry on with their normal execution. Say, for example, if a process requires maximum 10 frames, it can be started with only 5 frames under its disposal. That means the another remaining 5 frames can be used for another process. So in this way, when we are employing the concepts of multi-programming and virtual memory, we are dividing the entire physical memory into different processes or programs, and we can start a program even if we load only a part of that program into the memory. So in the coming slides, we will review some basic page replacement techniques and the different types of replacement algorithms that we have. So without wasting our time, we will proceed now. So what is the main theme of page replacement? The basic theme, that is, it works like this. Whenever a page fault occurs, that is, a particular page is not found in the physical memory, page fault will happen. And to service that page fault, first of all, the operating system should find the location of the desired page on the disk, and after that a free frame should be made available. If there is a free frame already available, then we can definitely use it. If there is no free frame, then we have to select a victim frame. Now, this victim frame may belong to the same process which was getting interrupted, or or the victim frame can be taken from another process also. So that is some kind of policy decision which we have to take into consideration. Now, after selecting uh, the victim frame should be written to the disk, and accordingly the frame and page tables should be changed to reflect the change. And after that, in the newly freed frame, we can load the desired page, and again we have to change the frame and page tables accordingly, and then we can resume the process which was being interrupted. Now, as the particular process uh, got the required page in the memory, then it has no problem of proceeding further. So in that way, different types of page faults can be serviced, and in doing so, we may have to replace some pages of the process also. That is the concept of page replacement. Now, some particular policy issues are there. The very first point is which page to be replaced. As I told you, you can replace a page from the same process which was getting interrupted due to page fault, or you can replace a page from another process which was in a waiting state at present. And so now which of these two options to choose? That is some kind of policy decisions that needs to be made. Another point can be page removed should be the page least likely to be referenced in the near future. Again, that is some kind of a mechanism that we can implement. And the third point is most of the policies predict the future behavior on the basis of the past behavior. Now, the way a particular process has behaved in the past, that means the particular pages that it referenced, we may study those references and we can assume the future request by taking or by studying that past behavior of the process and made some decisions accordingly. So these are basically some sort of policy decisions which needs to be taken care of. And at the very bottom part of this slide, you can see a graphical representation. So vertically, we are drawing the number of page faults, and horizontally, we are drawing the number of frames. Generally, it has been seen that whenever we are allocating more number of frames to a particular process, the number of page faults generally decreases for that process. That's a very common idea. That if, say for example, a particular page, say a particular process may require at most 10 number of frames for its execution. Now suppose there are two cases. In the first case, you are allocating only 5 frames to it, and in the second case, you are allocating 8 frames to the particular process. So in the second case, what will happen? The number of page faults will definitely decrease because we are already allocating more frames to the particular process now. So that particular behavior has been observed while studying the different types of page replacement algorithms. Now, popularly, there are 3 different kinds of page replacement algorithms that we have. First is the FIFO page replacement algorithm, that is called the first in, first out page replacement algorithm. Then we have the optimal page replacement algorithm. And lastly, we have the LRU, or recently or least recently used page replacement algorithm. So we will be studying all these 3 algorithms one by one. So if we focus on the FIFO page replacement algorithm, it is very easy to understand and program. Now take the example of a queue. You all know what does a queue mean. During ticket booking, many a times we have to stand in the queue. Generally, the person who comes first in the queue will also be serviced first. Now the same thing is happening here. The particular page which comes first is also been replaced first of all. So it can be implemented using some sort of queue data structure. The particular page which entered the queue first is also the first to be removed from the queue. So it is very easy to understand and program. We can easily program it using some sort of queue. And the second point is performance. It's not always good. So it does suffer from some performance issues. And lastly, it suffers from Belady's anomaly. Now this is a new term, Belady's anomaly. As I told you in the earlier slide, generally we have seen that whenever we are increasing the number of page frames allocated to a particular process, the page fault generally declines. But in some cases, it has been seen that whenever we have employed a FIFO page replacement algorithm and we have allocated more frames to a particular process, but still the number of page faults does not decrease, but it has increased in the reverse sense. So we can say that the FIFO page replacement algorithm suffers from Belady's anomaly. This is the problem which is known as the Belady's anomaly. That is whenever we are increasing the number of page frames to a particular process, the page fault rate always does not coming down. That is a particular problem, and the FIFO page replacement algorithm is a sufferer of this problem. Now we will review the mechanism of the FIFO replacement algorithm in a diagrammatic manner. Now in the slide you can see a particular reference string which is being shown here. The reference string consists of some pages which are as 0, 1, 2, 3, 0, 1, 4, 0, 1, 2, 3, 4. And you can see that there are 3 frames being allocated here. So we are being given 3 frames, and in that 3 frames we can load the corresponding or the specified pages for a particular process, and the reference string is already been shown here. So we will see the number of page faults that occurs in this case. We are assuming here that initially all the frames are empty. All the 3 frames are empty, and we will be loading those frames one by one, and we will be loading those frames whenever some page fault occurs. So the process initially does not contain any page in the memory. So for the first page, that is page 0, a fault occurs, and we will be loading page 0 into the memory frame. Next, we have frame 1 to be loaded, sorry, page 1 to be loaded, and it is been loaded in the second available frame, and then we are loading page 2. So after that, 3 frames are already occupied by 0, 1, and 2. Then we have the then we have the page number 3 that we have to include in our frames. Now see, at this point, all the frames are already allocated, so no free frames are there. Then what we have to do, we have to replace one frame here. We have to replace one page. We have to replace the content of one frame here, and we have seen that the first page that we entered is page 0. So we will replace page 0 by 3. So now the 3 frames will be containing the values, will be containing the pages 3, 1, and 2. Again, the next reference will be for page 0. So next we will replace page 1 with page 0 here, as because after 3 1 came after 0 1 came into the available free frame, so we will be replacing 1 by 0. So now the frames contain 3, 0, and 2, and then we have another page reference for page 1. So again, a page fault will be occurring. So now we will be replacing page 2 with 1, and then again we will be requiring page 4. So again, page 3 will be replaced because among the pages 3, 0, and 1, 3 came first, so we will be replacing 3 with 4, and so now the available frames will be containing the values pages 4, 0, and 1. So next two references are 0 and 1. Already those frames are present in the those pages are present in the memory, so no faults will be there, and correspondingly we will be getting a fault for page 2. So again, page 0 will be replaced by page 2 here, and then we will be getting a fault for page 3. So again, we will be replacing page 1 by 3 because 1 is the oldest frame here, and ultimately we will be requiring reference for page number 4, but already that page is in the memory, so no page fault will be there. So ultimately or finally we will be having 1, 2, 3, 4, 5, 6, 7, 8, and 9 number of page faults for this particular reference string. Our next page replacement algorithm is known as optimal page replacement algorithm. It has the lowest page fault rate among all the algorithms, and it's also free from Belady's anomaly. Now, what is the concept here? The concept is replace the page that will not be used for the longest period of time. That means you are taking some sort of future reference here. So it requires future knowledge of the reference string, and it is used for some sort of comparison studies only. Now, as the future knowledge is not very much easily gatherable, that's why it is generally used only for some sort of comparison studies. It is not, it cannot be implemented practically. So it is mainly used for some comparison purpose. So we will review this algorithm now. The same reference string is been shown here, same 3 number of frames. So we will start with page 0. So here fault is been occurring for page 0, then page 1, then page 2. So after this reference, all the 3 frames are occupied now, 0, 1, 2. And then we require page number 3, but page number 3 is not currently in the memory, so we have to remove one page here. Now which particular page to remove? That is the question. Now see, if you see the future request from this point onwards, here 2 will be required far apart. So we will be replacing 2 here. Sorry, uh, actually, after see, here we are faulting for page 0, then page 1, then page 2. So at this position, all the 3 frames are occupied. Next, we require page number 3 here. Now, uh, after reference 3, we have consecutive request for 0 and 1. 0 and 1 are already present in the frames here. But 2 will be needed for apart, so we will replace 2 with 3. So we will be getting 0, 1, 3 here. And then we require page 0 and page 1. So already those pages are present, so no page faults will be there. And then we require 4. Now see, 3 will be required far apart in this case. So we will be replacing page 3 with 4 here. So 0, 1, and 4. Now, next two references are for 0 and 1, so no page faults. Then it comes 2 here. Now, see, 4 will be required soon, and 0 will not be required anymore. So, we will replace 0 with 2 here. So, 2, 1, 4. Next, page fault will be there for page number 3. So what we can do, we can now replace page 1 here with 3, and ultimately page number 4 is already present, so no page fault here. So finally we are getting 1, 2, 3, 4, 5, 6, and 7. 7 number of page faults here for the same reference string. In the earlier case and in the present case, that means in FIFA and optimal, in both the cases, we have taken the same reference string, the same number of frames, but in case of optimal page replacement algorithm, we have got fewer number of page faults. Always optimal page replacement algorithm gives you the smallest number of page fault rate. So that's why it is very much useful. And lastly, we have the LRU page replacement algorithm, which is known as least recently used page replacement algorithm. It is also free from Beladi's anomaly, but one problem is there. How to order the frame defined by the time of last use. Now to solve that, two solutions are there using counters and some sort of two data structures. So next we will review the LRU page replacement algorithm with a diagrammatic representation. Again, the same reference string is being taken and the same number of page frames, 3. So in the same way, here page fault occurs for for page 0, next for page 1, next for page 2. Now all the 3 frames are occupied here, 0, 1, and 2. So next, the requirement is for page 3. Now which frame to replace? Now at this point of time, the least recently used frame is frame number 0. So we will replace 0 with 3 here. 3, 1, 2. Again, fault will be occurring for page number 0. So we will be replacing 1 now because it is the least recently used at this point. So 3, 0, 2. And then we will fault for 1 again. So replace 2 with 1. So 3, 0, 1. Now, again page fault will happen for page number 4. Now among 3, 0, and 1, 3 was the least recently used. That means 3 will be replaced here with 4. So now the frames will be containing 4, 0, and 1. Next, 0 and 1 are already there, so no page faults. Then again, fault will be happening for page number 2. Now 4 is the least recently used, so we will be replacing 4 here, because in the last 2 cases we have already used 0 and 1. So 4 is the least recently used, so we will be replacing 4 with the 2 here to 2, 0, 1. Again, page fault will happen for for page number 3. So we will be replacing 0 here with 3, and ultimately again a page fault will happen for page number 4. we will be replacing 1 here because it is the least recently used with 4. So ultimately, we are getting here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 number of page faults for LRU page replacement algorithm. So these are the 3 popular page replacement algorithms that we can implement as page replacement techniques. So with that, we will be concluding today's session here. Thank you.